Here's a paradox of our time. Humanity has never moved faster, yet never seemed so stuck. Our planes slice across continents in hours, our rockets leave Earth entirely, our digital messages cross oceans in less than the blink of an eye. We live in a civilization where your voice can circle the globe in less time than it takes you to inhale. And yet, for all this speed, our progress in wisdom lags embarrassingly behind. We still argue over the same tribal divisions that plagued our ancestors, still stumble over greed and fear, still treat our fragile planet as if we have another one in the garage, waiting. We are a species obsessed with speed, faster travel, faster computing, faster communication, and physics tells us there is a cosmic speed limit, the speed of light. Nothing, we are told, moves faster than 300,000 kilometers per second. It is the unbreakable barrier of Einstein's relativity, the ultimate governor of reality. And yet, what if it isn't? What if the speed of light is not the final word, not the cosmic finish line, but simply another chapter in the story of discovery? That question is not just scientific, it is philosophical. Because whenever humanity hits a limit, the real question is not whether nature set the boundary, but whether our imagination did. Let's go back a century. In the early 1900s, most physicists believed the universe was essentially solved. Newton's mechanics described motion. Maxwell's equations described electricity and magnetism. The machinery of reality seemed complete, like a watch with all gears accounted for. Then along came Einstein. He shattered the illusion, showing us that time itself is not absolute, that mass and energy are interchangeable, that light speed is not just fast but foundational. Suddenly, the universe was not the watch we thought it was, but something stranger, a fabric of space-time, stretching, bending, expanding. Einstein placed the speed of light as the boundary stone of reality. Faster than light travel? Impossible. Information exceeding that cosmic limit? Forbidden. Cause and effect, time itself, are safeguarded by this boundary. And for over a century, we've treated it not as a scientific model, but as a law of nature, ironclad and eternal. But history teaches us caution. Every time we have declared a boundary to be ultimate, the universe has humbled us. Once, the Earth was the center. Once, the atom was indivisible. Once, space was static. And each time, discovery shattered the walls of certainty. So why assume the speed of light is any different? To be clear, I am not saying we will casually break the light barrier like speeding on a highway. The math is unforgiving. Accelerating a massive object to light speed requires infinite energy. But what if the question is not about brute force, but about hidden doors? What if the fabric of space-time itself contains shortcuts? Loopholes, tunnels, wormholes, quantum entanglement, extra dimensions curled beyond our perception. Already, experiments in quantum physics have revealed phenomena that unsettle our assumptions. Entangled particles, separated by vast distances, behave as if they are linked instantly, as though space between them doesn't matter. Einstein himself derided it as spooky action at a distance, yet today it is a foundation of quantum information science. Does this transmit usable information faster than light? No, not in any way we currently understand. But it hints at something deeper, that our picture of speed, distance, and causality may not be complete. And here is where philosophy enters. If the universe places limits, are they walls or are they invitations? Every law of physics we've ever discovered was not a closure, but a doorway. The law of gravity seemed unbreakable until we learned to fly, not by defying gravity, but by working with it. The sound barrier once seemed final, until engineers discovered the aerodynamics of supersonic flight. Each impossible was not erased, but transcended, redefined by deeper understanding. Perhaps the speed of light is the next such threshold. Now, what does this have to do with us, with our lives, our societies, our choices? Everything. Because the speed of light, whether literal or metaphorical, is the symbol of limits. And humanity has always wrestled with limits, the limit of resources, of empathy, of cooperation. Too often we declare, that's just the way it is. That's the limit. But what if, like light speed, these are not ultimate laws, but boundaries of our imagination? Imagine if we applied the same determination we reserve for physics to our social and moral universe. Hunger? A limit? Or a problem solvable with distribution, technology, and will? Poverty? Inevitable? Or a failure of imagination? Climate collapse? Unstoppable? Or a test of whether we can act at planetary scale? The lesson of science is that boundaries are real, but rarely final. They are invitations to dig deeper, to ask better questions, to innovate. So when we ask, why might the speed of light not be the ultimate limit? We are not just asking about physics, we are asking about ourselves, about whether we are willing to accept boundaries as destiny or to see them as thresholds to cross. And perhaps the real speed limit is not 300,000 kilometers per second, but the pace at which humanity chooses to grow in wisdom. Before Einstein, the universe was a stage, a grand cosmic theater. Space was the backdrop, time was the ticking clock, and events simply played out upon them. That was Newton's cosmos, orderly, predictable, absolute. Space was space, time was time. And the two never mingled. Then came a quiet patent clerk in 1905, a man with no laboratory, no wealthy patrons, no university chair, with little more than chalk and imagination. Albert Einstein shattered the most basic assumptions of existence. He dared to ask, what if the speed of light is constant, no matter who measures it? The answer unraveled reality itself. Suddenly, space and time were not separate, but woven into a single fabric. Space-time and the speed of light was not just fast, it was the loom on which that fabric was woven. It was the ultimate conversion factor, stitching seconds into meters, braiding motion into duration, binding the universe together in a way no one had dared imagine. Einstein showed us that time itself is relative. A clock on a speeding train ticks slower than one at rest. Your heartbeat, your breath, your very aging slows as you approach light speed. Time is not a universal rhythm. It is a personal one, shaped by motion. And space, too, is pliable. Distances contract as you approach light speed. A voyage across the stars that would take millennia from one perspective could take mere decades for the travelers. To move faster is not to move through space, but to alter the very fabric of space and time around you. The implications were staggering. The universe was no longer the fixed stage we thought it was. It was a dance floor, bending and swaying with mass and motion. And the speed of light, 300,000 kilometers per second, wasn't just a limit, it was the choreography. The rule book of the cosmic waltz. But Einstein didn't stop there. 10 years later, with his general theory of relativity, he revealed something even more astonishing. Gravity is not a force pulling masses together. It is the curvature of space-time itself. Planets orbit stars not because of invisible strings tugging at them, but because stars bend the fabric and planets follow the curves. We are not held down by a force, we are surfing the shape of reality. Think about what that means. You, sitting here, listening to these words, are not pinned to your chair by gravity. You are following the contours of space-time that Earth creates around you. You are gliding along invisible curves as surely as a marble rolls along a funnel. That is what Einstein gave us, the realization that we are not separate from the fabric of the universe, we are woven into it. And yet, with all its elegance, relativity came with a sting. The speed of light is absolute. No information, no matter, no influence can travel faster. It is the ultimate speed, the cosmic governor, the final frontier. Or is it? Because here's the thing, every time humanity has declared a frontier final, it has eventually been crossed. The sound barrier once shattered planes and pilots. Today, we casually break it. Flight was once impossible until it wasn't. The oceans were once the edges of maps until someone dared to sail past them. So perhaps the speed of light is not the ultimate limit. Perhaps it is the edge of the map, the here be dragons of physics. Perhaps beyond it lies a deeper truth we have yet to imagine. And this is why Einstein's revolution is more than physics. It is philosophy. It teaches us that what we consider unchangeable may simply be unexamined. That reality, when pressed, yields to imagination. That limits are not always the end, they are invitations. The question then is not whether the speed of light is unbreakable. The question is whether we, like Einstein, are willing to look at the universe differently. To risk sounding absurd, to dare to say, what if? Because every leap humanity has ever taken began not with certainty, but with doubt, not with answers, but with questions. And the speed of light may be the next great question. If Einstein gave us a universe of curves and constants, quantum mechanics gave us a universe of paradoxes. It is the science of the very small atoms, electrons, photons, and yet it governs everything. Without it, there are no stars shining, no chemistry forming, no electronics humming. Quantum mechanics is not just a detail of physics. It is the operating system of reality. But here's the catch. It defies common sense. A particle is not here or there, it is both, until measured. It does not travel along one path, it travels along all possible paths simultaneously. Reality, at the quantum level, is not a clean line. It is a haze of possibilities, a shimmering fog of maybes. And among its strangest revelations is something that troubled Einstein to the end of his life: entanglement. Imagine two particles born together in a single quantum event. They drift apart across a room, across a galaxy, across light years of empty space, and yet somehow they remain linked. Measure one, and the other responds instantly, as though distance doesn't exist. Tug at one thread, and the other quivers, no matter how far away it is. Einstein called it spooky action at a distance. And he didn't mean it as a compliment. He believed physics should be local, things should only affect their immediate neighbors, not leap across space faster than light. But experiment after experiment has shown spooky action is real. Entanglement is real. The universe has threads that stretch invisibly across space, linking particles in ways that seem to defy the speed limit. Now, let's be precise. Entanglement doesn't allow us, at least not yet, to send messages faster than light. You cannot use it as a cosmic telegraph. The math forbids it. But still, the instantaneous correlations exist. Nature is telling us something, that our picture of separation, of distance, of communication is incomplete. Think of it this way. Relativity says nothing outruns light. Quantum mechanics says distance may not matter at all. Put those two together, and you get the most profound tension in physics. A tension that suggests we are missing a piece of the puzzle. And here's where the metaphor expands. How often in human life do we assume distance is absolute? We divide ourselves by geography, by borders, by oceans, by cultures. We assume that what happens over there does not touch us over here. And yet, the reality of Earth has always been entangled. A virus emerging in one city can spread to the world in weeks. Carbon emitted in one nation warms the whole planet. The fate of rainforests in South America affects the air we breathe in Asia, Africa, Europe. We are entangled, whether we recognize it or not. Entanglement is not just physics, it is a mirror. It reminds us that the separations we cling to are illusions, that what we do here ripples elsewhere, that the speed of compassion, like the speed of quantum information, can be instantaneous if we allow it to be. So perhaps the lesson of quantum mechanics is not simply that particles can defy distance. Perhaps it is that humans can too, not by violating physics, but by transcending indifference. The limit is not the speed of light. The limit is how quickly we choose to care. And maybe that's the real spooky action at a distance, empathy. The ability for one life to affect another instantly without waiting for permission. Still, the scientific mystery remains. Entanglement has no mechanism we understand. No signal, no medium, no journey. Just a leap across the void. Does it hint at hidden dimensions? At a deeper reality where distance is irrelevant? At channels of connection beyond light itself? We don't know. But the very existence of the question suggests the speed of light may not be the ultimate story. It may be the speed limit of one layer of reality, but not of all layers. And if that's true, then the universe is not just stranger than we imagine it is, stranger than we can imagine. Which brings us to the next frontier. Wormholes, warp drives, and the possibility that the very fabric of space-time itself might hold shortcuts through the cosmic speed limit. If relativity insists that nothing can outrun light, then perhaps the trick is not to outrun it at all. Perhaps the trick is to change the track. Einstein himself gave us the clue. Space and time are not fixed backgrounds, but a fabric stretchable, bendable, malleable under the weight of mass and energy. And if space-time is a fabric, then maybe the way past the light barrier is not to run faster across the fabric, but to fold the fabric itself. That idea leads us to wormholes. Imagine space-time as a sheet of paper. 2 points on opposite ends are far apart. A beam of light would take time to cross the distance. But what if you fold the paper, bringing the 2 points together and punch a hole through? Suddenly, what was distant becomes adjacent. That is a wormhole, a tunnel through space-time, a shortcut that bypasses the normal rules of distance and speed. The equations of general relativity allow them. They are not fantasy, at least not mathematically. In fact, black holes themselves may be related to wormholes, though their throats collapse too quickly for anything to pass. To hold a wormhole open, physicists speculate you'd need exotic matter material with negative energy density, the kind that only quantum fields seem to hint at. Do we know how to do this? Not yet. But the door is cracked open, and that alone is extraordinary. Then there's the idea of a warp drive, not traveling faster than light through space, but compressing space in front of you and expanding it behind you. Imagine riding a wave, not plowing through water, but letting the water itself carry you forward. That's what physicist Miguel Alcubierre proposed in 1994, a bubble of space-time that moves faster than light, carrying whatever's inside without violating relativity. Again, the mathematics works. The challenge? The energy required seems absurd more than the mass of the universe. Unless, of course, future physics finds a loophole. And that is the pattern we see again and again. What seems impossible today may become routine tomorrow. Heavier than air flight was dismissed as fantasy until it wasn't. Splitting the atom was once unthinkable until it was harnessed for both destruction and power. The moon was unreachable until footprints marked its surface. Wormholes and warp drives are not today engineering projects. They are questions. Questions that remind us the universe is not fully mapped, that what we consider barriers may simply be boundaries of our current knowledge. But let's not lose the metaphor, because wormholes are not just physics, they are philosophy. They represent the possibility of shortcuts, of connections across seemingly impossible divides. Humanity, too, faces vast distances, not of light years, but of understanding. Distances between cultures, nations, ideologies, distances between the privileged and the suffering, between wealth and poverty, between knowledge and ignorance. And maybe the lesson is this: if we can imagine folding space-time to bridge galaxies, can we not also imagine folding empathy to bridge humanity? If we can dream of warp drives, can we not also warp the stubbornness of our own divisions, bending them until what seemed far apart becomes close? Because here's the paradox. We long for shortcuts through the stars, yet we resist shortcuts through our prejudices. We dream of wormholes, yet ignore the bridges we could already build here on Earth. So perhaps wormholes will one day connect us across galaxies, but until then, the wormholes we most urgently need are not in physics, but in philosophy, in how quickly we can leap across fear, across division, across apathy to meet one another. And maybe that's the real warp drive, not bending space, but bending ourselves. Still, the scientific dream remains. Wormholes, warp drives, gateways in the fabric of reality. Each a reminder that the speed of light may not be the end, but the edge. And beyond that edge lies not certainty, but wonder. If you want to understand why the speed of light may not be the final barrier, you don't have to start with Einstein. You can start with us human beings, stumbling across history, again and again declaring something impossible, only to discover it wasn't. Take flight. For millennia, humans looked at the birds with envy. The skies belong to wings, not to us. The idea of heavier-than-air flight was mocked as folly. Learned men, engineers of their age, insisted it was impossible. And then came two bicycle makers from Ohio. In 1903, Orville and Wilbur Wright flew a machine heavier than air for 12 seconds. Just 12 seconds. But in those 12 seconds, reality changed. The impossible bent. And less than 7 decades later, humans had flown not just through the sky, but to the moon. The sound barrier was another. As aircraft grew faster, pilots approaching the speed of sound found their planes rattling apart, their controls sluggish, their engines failing. Newspapers spoke of a sonic wall. An ultimate boundary nature had set. Then, in 1947, Chuck Yeager climbed into the Bell X-1 and pushed through Mach 1. The barrier wasn't a wall, it was a threshold. And once crossed, it became routine. Today, we break it without a second thought. Space itself was once the ultimate limit. For most of human history, the sky was ceiling enough. Then, in 1961, Yuri Gagarin circled the Earth. In 1969, Neil Armstrong stepped onto the lunar surface. Humanity had left the cradle. We had broken the boundary that separated us from the stars. Notice the pattern. Every impossible was absolute until it wasn't. Every boundary was treated as natural law until courage, curiosity, and persistence proved otherwise. Now consider the speed of light. Today, we treat it as the ultimate wall, the horizon of possibility. But history whispers to us, be careful. Every time we have declared thus far and no further, we have underestimated both nature and ourselves. This is not naive optimism. It is humility. Because to believe the speed of light is absolute is, in a way, to repeat the arrogance of those who thought flight was for birds, or that sound was an impenetrable wall, or that Earth was the center of all things. It is to confuse the limits of our imagination with the limits of reality. And here's the deeper truth. Even if the speed of light cannot be broken, it can be transcended. Wormholes, warp bubbles, entanglement, these do not break the rules. They reveal deeper ones. And history shows us that progress does not come from defying nature, but from understanding it more profoundly. But let's step back and ask, why does this matter? Why should the speed of light or any physical limit concern us in our daily lives? Because the speed of light is more than physics. It is a metaphor. It is the symbol of every wall we encounter, scientific, social, personal. The speed of light is that voice that says, you can't, and the history of humanity is the story of answering back. Watch us. We live in a universe where stars die to create the elements in our bodies, where galaxies collide in slow motion dances, where black holes warp reality itself. To assume we have already mapped the ultimate limits of such a universe is not science, it is hubris. The real question is not whether the speed of light is absolute. The real question is whether our courage is. Because if history shows us anything, it's this. Boundaries exist to be tested, questioned, transcended, and maybe, just maybe, the next impossible to fall will be light speed itself. Speed has always fascinated us. From the first time a human sprinted across an open field, to the first chariots, to steam engines, to jets, to rockets, we've measured progress by how quickly we could move. We celebrate speed records, invent faster machines, marvel when something breaks through to a new velocity. But here's the paradox. While our technology accelerates, our wisdom seems trapped in slow motion. We can send a message across the globe in less than a heartbeat, yet still fail to listen to the person across the table. We can simulate galaxies on supercomputers, yet struggle to sustain the ecosystems in our own backyards. We can design missiles that travel at hypersonic speeds, yet hesitate to solve the basic problem of hunger. We can build algorithms that predict your shopping habits before you're even aware of them, yet stumble when it comes to predicting compassion. This is the real imbalance of our age. Technology moves at near light speed. Morality crawls. Think about this. The same ingenuity that gave us nuclear power also gave us nuclear weapons. The same brilliance that gave us the internet also unleashed disinformation at unprecedented scale. The same tools that let us sequence genomes also tempt us to alter life in ways we may not yet be wise enough to control. Every leap in speed carries a shadow. Every new gear in the machine demands an equal upgrade in responsibility. And too often, responsibility lags behind. Maybe this is the true cosmic irony. The ultimate speed limit may not be the speed of light, it may be the speed at which humanity learns to match wisdom to power. Because if wisdom doesn't catch up, then our speed is not progress. It is momentum towards self-destruction. It is acceleration without direction. It is a rocket without a navigator, burning brighter and faster until it crashes. History warns us of this. Rome's roads were the fastest in the ancient world, but they carried both commerce and conquest. The age of exploration connected continents at unprecedented speed, but also carried exploitation and disease. The Industrial Revolution accelerated production, but also accelerated inequality and environmental collapse. Speed without wisdom does not liberate, it destabilizes. So here we are in the 21st century, with rockets that can leave the Earth, networks that link billions of minds, and machines that can calculate trillions of operations per second. And yet wars still rage. Prejudice still poisons. Children still starve. The question isn't whether we can move faster. The question is whether we can grow wiser, and maybe that's the true challenge behind the speed of light. It is not just a question of physics, it is a metaphor for balance. Can we match our velocity with vision? Can we ensure that the pace of technology is matched by the pace of empathy? Can we make sure that our reach across the cosmos is not greater than our reach across the table, across the border, across the generations yet unborn? Because here's the truth. Breaking the speed of light, if it ever happens, will not save us from ourselves. A species that cannot care for its own planet has no business colonizing others. A civilization that cannot balance wisdom with power has no business commanding the stars. The real test is not whether we can outrun photons. The real test is whether we can outgrow ourselves, and maybe, just maybe, the speed of light was set not to hold us back, but to give us time. Time to evolve, not in physics, but in philosophy. Time to prove that we are not just clever, but wise. Time to learn that the fastest journey is not through space, but through the heart, through compassion, cooperation, and courage. So the question remains, will we accelerate only in technology, or will we accelerate in wisdom too? Will we move fast enough to match our power with responsibility? Or will we discover too late that the only speed limit that mattered was the one we set for ourselves? If you want proof that humanity can surpass what once seemed impossible, you need only look back to the middle of the 20th century. The space race was born in fear, in rivalry, in the dangerous competition of two superpowers locked in a Cold War. Nuclear arsenals swelled, suspicion poisoned diplomacy. The future seemed perpetually perched on the edge of catastrophe. And yet, out of that crucible of fear came a dream larger than fear itself. The dream of space. In 1961, Yuri Gagarin became the first human to orbit Earth. Think about what that meant. For the first time in 5 billion years of planetary history, life had climbed out of the biosphere that birthed it and looked back upon the world from above. Gagarin's words, "I see Earth. It is so beautiful," weren't just a report, they were a revelation. Reality had expanded. Just 8 years later, Neil Armstrong and Buzz Aldrin walked on the moon. In that moment, the impossible fell. A creature born of dust and starlight, nurtured in caves, raised in cities, fueled by mathematics and courage, left footprints on another world. But perhaps the greatest legacy of Apollo wasn't the footprints. It was the perspective. The famous photograph of Earth rising above the lunar horizon, Earthrise, showed our home as a fragile marble, a shimmering oasis in the infinite dark. No borders, no nations, no divisions, just one planet. That single image has been credited with sparking the modern environmental movement. Not because it told us something new, but because it showed us what was always true. Earth is one. Humanity is one. And if we fail to care for it, there will be no second chance. The space race is often remembered as a triumph of technology, but it was more than that. It was proof of what happens when humanity chooses the branch of possibility that leads upward. In a time of suspicion and hostility, we proved that we could transcend boundaries of imagination, that impossible was not a wall, but a horizon. And yet, here is the irony. We left footprints on the moon half a century ago. Since then, our ambitions have faltered. The Apollo program ended. Humanity turned inward. We built faster computers, smaller devices, more powerful economies, but we stopped reaching as boldly for the stars. We surpassed the limit of the moon, only to stall on the launch pad of our own hesitations. The space race shows us a truth that is as relevant today as it was then. Surpassing limits is possible, but it requires more than technology. It requires will. It requires imagination. It requires the ability to look beyond rivalry and fear towards something greater than ourselves. And here's where the metaphor deepens. The space race was not just about rockets. It was about identity. It asked, who are we as a species? Do we define ourselves by the weapons we build or the horizons we cross? By the boundaries we defend or the frontiers we explore? Today, we face a new race, not between nations, but between futures. One future where we continue to burn fossil fuels until climates collapse, where oceans rise, where ecosystems unravel. Another where we invest in sustainability, in cooperation, in stewardship. One future where technology accelerates without wisdom, where power outpaces responsibility. Another where we grow not just in speed, but in empathy. The space race reminds us, the choice is ours. Limits exist. But so do breakthroughs. And the greatest breakthroughs are not in machines, they are in perspective. So perhaps the question is not whether the speed of light can be broken. Perhaps the deeper question is whether we can break the limits within ourselves, the limits of vision, of cooperation, of care. Because if we can, then the stars are waiting. And if we cannot, then no technology will save us from ourselves. The space race gave us a glimpse of what is possible when we choose boldly. The question is, will we choose again? The Apollo missions were humanity's proof of concept that impossible goals could be reached when vision and willpower aligned. But the moon was never the ultimate destination. It was a mirror showing us Earth, fragile and finite, hanging alone in the black. And today, that mirror has become unavoidable because the challenge before us is not the moon. It is not Mars. It is Earth itself. Climate change is not a distant speculation. It is here, measurable, undeniable. Carbon dioxide levels higher than at any point in human history. Ice sheets thinning, seas rising, wildfires more intense, storms more destructive, droughts more unforgiving. The very systems that sustain life are shifting, and the warning lights on our planetary dashboard are flashing red. This is our space race. Just as the 1,960 seconds asked humanity whether we could reach beyond Earth, the 21st century asks whether we can preserve. One challenge was technological. Build a rocket, land on the moon. The other is moral. Can we unite as a species to protect our shared home? Both are about limits. The space race asks if we could surpass the limit of gravity. The climate crisis asks if we can surpass the limit of greed. In one branch of the future, we act. We invest in renewable energy, reforest landscapes, transform agriculture, decarbonize economies. We innovate boldly, not for conquest, but for survival. In another branch, we delay. We squabble. We tell ourselves the problem is too big, too expensive, too inconvenient. And in that branch, Earth itself becomes the impossible limit, the one barrier we cannot cross because we destroyed it from within. The multiverse of the future is already branching. The question is, which reality will we inhabit? And here's the irony. Solving climate change requires no new laws of physics, no wormholes, no warp drives, no exotic matter. It requires only will, cooperation, imagination, the same qualities that carried us to the moon. We already have the technology. We already know the steps. What we lack is the speed of action. Think about that. We wonder whether light speed can be broken, but the greater question may be whether apathy can. Because what good is reaching another star system if we cannot preserve the only oasis we know? What good is dreaming of warp drives if we cannot protect the rivers, forests, and atmosphere that sustain us? This is why climate change is more than an environmental issue. It is a cosmic one. Because if we fail here, then we fail not just as a species, but as the universe made conscious of itself. Out of billions of galaxies, billions of stars, billions of planets, we are the only ones, so far as we know, who can reflect on existence. If we collapse, meaning collapses with us, at least in this corner of reality. So yes, the speed of light may be the fastest anything can move. But wisdom, our ability to act with foresight, needs to move faster still. Faster than denial, faster than division, faster than the inertia of old habits. Because the test is upon us, and delay is its own form of failure. This is our moon landing, our Apollo 11. The defining challenge that will decide whether humanity is remembered as a species that squandered its gifts or as one that matured in time to save itself. And just as the Saturn V rocket was a symbol of what humanity could build, perhaps the clean energy systems, rewilded landscapes, and cooperative institutions of the 21st century will be our next Saturn V. Proof that we can bend not just physics, but ourselves toward possibility. The space race asked if we could leave Earth. This race asks if we deserve to. If the speed of light is the boundary stone of relativity, then hidden dimensions may be the cracks in the wall, glimpses of a deeper structure beneath the fabric of space-time. In Einstein's equations, space has 3 dimensions, and time adds a 4th. That's the stage on which all of physics unfolds. But in the 20th century, new theories began to whisper. Perhaps 4 dimensions are not enough. Perhaps the universe has more 5, 10, maybe 11 dimensions curled so tightly we cannot see them. Like threads woven into fabric too fine for the naked eye, they might shape reality in ways we barely perceive. String theory, for instance, suggests that all particles are tiny vibrating strings, their notes determined by dimensions beyond our senses. These hidden dimensions could explain why gravity is weak, why the universe is balanced just so, why the laws of physics seem tuned for life. If true, then what we call reality is just the shadow of a deeper architecture, one where limits like the speed of light may not apply in the same way. And here, science meets metaphor. Because just as physics hints at hidden dimensions, so too does human life. Think about it. How often do we live as though the world is flat, two-dimensional in its simplicity, only to discover hidden layers of complexity? A stranger's life contains dimensions we will never know. A culture different from ours contains histories, struggles, triumphs invisible to us until we look closer. Every human story is a universe of hidden dimensions folded just beyond the edge of perception. We assume limits are absolute limits of empathy, of cooperation, of what is possible. But what if, like space-time, those limits are only the projection of something deeper? What if hidden dimensions of compassion, creativity, and resilience exist within us, waiting to be unfolded? The search for parallel universes also asks us to expand. If other realities exist, then this one is not the only one, but it is the only one we can touch. Out of infinite possibilities, we live here, on this earth, in this time. And that makes this universe precious beyond measure. It's easy to imagine other universes where humanity made better choices, where war was avoided, where ecosystems were preserved, where wisdom matched technology. But imagining those universes does not absolve us, it challenges us. Because our children will not live in those universes. They will live in this one. And this one will bear the weight of what we do or fail to do. So perhaps the real hidden dimension is responsibility. The layer beneath all physics, all speculation, all possibility. The truth that no matter how many universes may exist, we are bound to this one by duty. Parallel universes remind us that reality is stranger, bigger, and richer than we think. But they also remind us that meaning is not found in infinity. It is found in presence, in action, in this fragile thread of existence that we hold. And maybe that's the paradox. To search for other universes is to discover how deeply this one matters. To look for hidden dimensions is to be reminded of the dimension of choice, the one dimension that defines us above all. Because physics can tell us how fast light travels, but only philosophy can tell us how fast responsibility does. And that may be the truest speed limit of all. For more than a century, we've treated the speed of light as the ultimate barrier. Faster than 300,000 kilometers per second? Impossible. That's the cosmic governor, the universe's final word. But here's the irony. Even if tomorrow we discovered a way to bypass light speed, it wouldn't solve the greatest challenges we face. Because our true limits are not written in Einstein's equations. They're written in our behavior. What good is a warp drive if we cannot curb the burning of our own atmosphere? What good is a wormhole if we carry through it the same divisions, hatreds, and blindness that plague us here? What good is reaching the stars if we have not learned to take care of the single planet that birthed us? The real speed limit may not be physical at all. It may be moral. It may be the speed at which humanity learns to align wisdom with power. Think about our story so far. In just a few centuries, we've unlocked nuclear energy, decoded DNA, harnessed artificial intelligence, mapped the cosmos. We've accelerated from horse-drawn carts to rockets in the blink of evolutionary time. But in empathy, in cooperation, in foresight, we move at a crawl. We are like a child who's been given the keys to a race car before learning to steer. The acceleration is breathtaking, but so is the danger. And this is where the metaphor of light speed becomes urgent. Because just as physics insists we cannot outrun light, history suggests we cannot outrun ourselves. The faster we go, the more catastrophic the consequences if wisdom doesn't keep pace. But here's the hopeful twist. Every time humanity has faced a limit, we've eventually transcended it. Not just in technology, but in morality. Slavery once seemed permanent until it wasn't. Segregation once seemed immovable until it fell. Women's exclusion from science, politics, education, once treated as natural law, crumbled under the weight of persistence and justice. Moral progress, like scientific progress, is slow, uneven, fragile. But it happens. So maybe the question is not, can we break the speed of light? Maybe the question is, can we break the speed of indifference, the inertia of apathy, the drag of division? Because if we can, then surpassing light speed will be trivial compared to what we've already accomplished. A species learning to care beyond itself. A civilization learning that the greatest frontier is not distance, but empathy. Not velocity, but vision. In physics, we ask, what is the ultimate speed? In philosophy, we must ask, what is the ultimate responsibility? And maybe those questions are the same, because the universe does not need us to travel faster than light. It needs us to grow faster than hate, to outrun short-sightedness, to accelerate toward wisdom before the engines of our technology outrun our control. If we succeed, then one day we may indeed fold space-time, leap through wormholes, surf warp bubbles. But if we fail, then none of that will matter. Our race will end not with the crack of physics, but with the silence of squandered possibility. So perhaps the truest cosmic challenge is this: to see that the real light speed barrier is not out there among the stars, but in here, in the choices we make. And if we can break that barrier, if we can accelerate wisdom to match our power, then there is no limit in physics or philosophy that we cannot surpass. The speed of light has always been more than a number. It is the universe's poetry, a rhythm woven into the fabric of space-time, a boundary that defines how cause leads to effect, how now becomes then. For over a century, we've treated it as the ultimate limit. But perhaps it isn't. Perhaps, like every barrier before it, it is only a threshold, waiting for us to discover what lies beyond. And yet, here is the deeper truth. Even if we never break it, even if no warp drive is ever built, even if wormholes remain the stuff of mathematics and dreams, the question of the speed of light has already given us something greater than travel. It has given us perspective, because it reminds us that limits are not destiny. They are challenges. And humanity's story has never been about obeying boundaries. It has been about testing them, questioning them, surpassing them. From fire to flight, from the atom to Apollo, every impossible has eventually yielded to imagination and will. But the greatest test before us is not written in physics. It is written in ourselves. The real speed limit is the pace at which wisdom can catch up to power, the pace at which empathy can catch up to technology, the pace at which we learn to see not as tribes, not as nations, but as earthling stewards of a fragile oasis suspended in the dark. The space race proved we could reach beyond rivalry to accomplish the extraordinary. But it also left us with the most important photograph ever taken, Earthrise. That image told us that the true frontier is not out there among the stars. It is here on this blue marble, finite and fragile, home to everyone you love and everyone who has ever lived. Today, we stand in our own race. Not a race to the moon, but a race to maturity. A race against climate collapse. A race against indifference. A race against ourselves. One path leads to despair, division, destruction. Another to sustainability, cooperation, survival. Both paths exist, like branches of the multiverse, waiting for us to choose. But only one will become real. So when we ask why might the speed of light not be the ultimate limit, we are not only asking about photons, we are asking about possibility, about whether we will accept boundaries as permanent or see them as invitations, about whether we will settle for survival or reach for significance. And maybe the answer is this: the speed of light is not the final barrier. The final barrier is the courage to imagine more, to care more, to do more. And that barrier, unlike physics, is entirely in our hands. The universe is vast. It does not need us. Stars will burn, galaxies will spin, black holes will swallow long after we are gone. But meaning the ability to look at the stars and wonder, the ability to ask questions like this one, the ability to dream of limits surpassed, that is rare, that is precious. And as far as we know, it exists nowhere else but here. So let us rise to the responsibility. Let us move faster than indifference, faster than division, faster than fear. Let us accelerate wisdom until it matches our power. Let us choose the path where humanity endures, where Earth thrives, where the story of life continues, not just on one planet, but across the stars. Because if there is one truth the speed of light teaches us, it is this: time is finite. The universe will not wait. The choice is ours. And when future generations look back, let them say, here was a species that saw the limits of its age, that stared at the walls of its own ignorance, that wondered about the speed of light and chose not to stop at the boundary, but to step through it, not with arrogance, but with humility, not with recklessness, but with responsibility, not just with speed, but with vision. And maybe then, when we have learned to match our power with wisdom, when we have proven that we deserve to carry consciousness into the cosmos, the universe will whisper back what it has always been waiting for us to hear. The speed of light was never the ultimate limit. The ultimate limit was you. We began with a paradox. Humanity has never moved faster, yet never seemed so stuck. Physics gives us the speed of light as the ultimate barrier, but history shows us that every impossible eventually yields to imagination. Wormholes, entanglement, hidden dimensions, these remind us that reality is not yet fully mapped. But the deeper truth is this: the most urgent limits are not in the stars. They are within us. The real speed limit is the pace at which wisdom matches power, the pace at which empathy keeps up with technology, the pace at which we learn to care for one another and for the fragile planet that cradles us. The space race showed us what happens when we aim higher than fear. Out of rivalry came one of humanity's greatest achievements. And the photograph of Earth rising above the moon showed us the truth we needed all along, that we are one world, one species, one chance. Now we face our own frontier. Climate change, inequality, conflict, these are the event horizons of our time. Beyond them lies either collapse or renewal. Both futures exist as possibilities, but only one will become real, and the choice is ours. So perhaps the speed of light is not the ultimate limit. Perhaps the true barrier is whether we can accelerate wisdom faster than fear, responsibility faster than division, imagination faster than apathy. And if we choose that path, then no law of physics, no boundary of space-time, no cosmic constant will ever be beyond us. Because the universe is vast, but meaning is rare. And as far as we know, meaning exists here within us. That is our gift. That is our responsibility. So let us be the species that prove the ultimate limit was never light at all. The ultimate limit was us, and we chose to break it.